So in this video, we're going to talk about the alternating series estimation theorem, which I had introduced in the previous video. And so if we look at this, I guess this number line, or the staggered number line, we can kind of see that the S4, so the sum of the first four terms, and the true sum of this series to infinity is of this distance. So this funky distance here. And then the S5 to the sum of infinity is this distance. And as we use more terms, our approximation to infinity becomes closer and closer. But what we can also see is that S5, the distance between S5 to infinity, will actually never be greater than the term S5. And so in a more mathematical way of putting it, we say that the sum of the sum of the series, which we call S, or actually instead let's just call sum of the series from n equals to 1 to infinity of, let's go back and use a harmonic series of -1, or alternating harmonic series, the power of that this is equal to the sum from n equals to 1 to infinity of -1 over n, -1 to the power of n, plus, I did not want to count to infinity, so I had wanted to count to, say, 6, or not even 6. I don't know how to add up to 6. Let's use 3. If we were to try to approximate the sum of our entire series by adding the first 3 terms, how far off would we be? So graphically, we can see that we'd be off by this distance. But what is the upper bound of that distance? And so this, in a sense, is what we know as our error term. And what we can kind of see is that our error term will never be greater than the next term of our sequence, 1 over 4. Because so the sum from n to 1, from the sum of the series from n equals to 1 to 3 is equal to, this is S2, this is S2, and then this is S3, and then this is S4, or actually we just needed S3. And so S4 has already gone, when we go from S3 to S4, our S of infinity is actually somewhere between this. And so graphically we should be able to see that S3, once we add 1/4 to it, we've passed our limit of S, we've passed the number that we wanted to achieve at, which is what the true value of series is when you sum from 1 to infinity. And so we can see that the distance between S3 and S to infinity will never exceed S of 4. Or not S of 4, but actually will never exceed A of 4. And so we can say that our error term is actually just whatever our next term is. So to put into more general forms, the error term of n equals 1 to infinity of -1 to the power of an is equal to the sum of n equals 1 to whatever number you want to add up to. Let's call it big N, of -1 an, plus, and your error term will just be the next term, so it'll be an plus 1. Because if we're summing up to n, then our next term is m plus 1. And that's all the alternating series estimation theorem states.